Good afternoon, ladies and gentlemen. Good afternoon, good evening, ladies and gentlemen. You're welcome to our webinar series 1, Forum Webinar Series 1, Sharing What Works, the Future of Food Security in Sub-Saharan Africa. I am Roland Agaba, your moderator. It's a pleasure to have you join us in this webinar today. And we look forward to wonderful deliberations about the future of food security in Sub-Saharan Africa. Ladies and gentlemen, Sub-Saharan Africa is a highly populated region of Africa below the Sahara with over 1.2 billion people. And of these 1.2 billion people, about 3 million people are undernourished, with over 55 million children stunted. And we have over 140 million people who are undernourished in a very critical food insecure situation. In this part of the world, we have over a quarter of the world's arable land. So a quarter of the total world's arable land is in this part of the world. Yet, at least 1 in 5 of the inhabitants of Sub-Saharan Africa go to bed hungry every day. Now, this means we are faced with a daunting task as researchers, as academicians, as policymakers, as a people, to find solutions that will help us feed the future. Now, this population of 1.2 billion people will increase to 2.7 billion people by 2060. This means we'll have to equally double the efforts to feed the continent. I want to welcome you once again to this webinar today. And as I welcome you, I want to welcome the executive assistant to the executive secretary of the forum, Dr. Sokona Dagnok, to give opening remarks. And thereafter, I will introduce to you the panelists who will take us through a number of critical topics of discussion and raise great insights into how we can feed the Sub-Saharan Africa going forward. Allow me to welcome Dr. Sokona Dagnok, the executive assistant to the executive secretary of RUForum. Thank you very much. Welcome, madam.
Thank you very much, Dr. Agaba. Distinguished guests, RUForum community, participants of this webinar, ladies and gentlemen, it is my honor, on the name of the RUForum Executive Secretary and on my own behalf, to welcome you all at this webinar, the first of a series of RUForum webinars to discuss food security. Ladies and gentlemen, the UN Food Systems Summit held in September 2021 in New York retained 5 key action tracks and called for stakeholders to partner, to interact, to work together to deliver on these 5 interconnected action tracks, which are ensure access to safe and nutritious food for all. Action track 2, shift to sustainable consumption patterns. 3, boost nature, positive productions. 4, advance equitable livelihoods, and 5, build resilience to vulnerabilities, shocks, and stress. Distinguished guests, ladies and gentlemen, allow me to recall that RUFORUM has contributed greatly to the deliberations of the UN Food Systems Summit by supporting many countries of its member universities organize their national dialogues to feed into the resolutions of the Food Systems Summit. Today's webinar, entitled The Future of Food Security in Sub-Saharan Africa, Sharing What Works, is a continuation of RUFORUM efforts to deliver on these 5 action tracks. The proposed webinar that brings together key speakers from different geographic regions of Africa, namely Southern Africa, Eastern Africa, and Western Africa, is yet an attempt of RUFORUM to fulfill its commitments towards the African Union agendas, for which RUFORUM is one of the key implementing partners. I would like to mention a few, like Agendas 2063, STISA 2024, C10, and CADEP, among others. Ladies and gentlemen, distinguished guests, it is my pleasure to acknowledge the participation of academicians, students, research institutions, policymakers, private sector, and other stakeholders to this event. The active participation of everyone here in this virtual room to the discussions on the future of food security in Sub-Saharan Africa is highly expected. I thank you all for joining this webinar today. My special thanks are for our distinguished speakers and to the moderator, and also to the RUFORUM organizing team. I wish you all successful deliberations. Thank you very much.
Thank you very much, Dr. Sokona, for that wonderful opening remarks. Ladies and gentlemen, we will have today presentations from a number of distinguished scholars and scientists across Africa with a lot of expertise in agricultural research, technology development, and transfer. We'll have a keynote address, Accelerating Plant Breeding and Biotechnology to Feed Africa. We will have another presentation of plant genomics in Africa, present and prospects, by Dr. James Morolo. We will have a presentation, Trends in Crop Improvement of Underutilized Crops, by Dr. Kumi Frank. We will have a presentation by Dr. Prosi Isibikalu, Making Participatory Plant Breeding Inclusive for Africa, for Feeding Africa. And then we will have another presentation by Dr. Afang Baji, addressing African hidden hunger and equity. Ladies and gentlemen, on this program, we will have an opportunity to have a panel of discussion at the end of these presentations. Ladies and gentlemen, our next presentation is going to be made by Dr. Cosmos Magorokoso. He is a co-founder of Innova Africa Genetics, a unique startup that breeds and licenses preparatory climate-smart varieties. He is an experienced breeder. He has worked with CIMMYT, the World Vision, and has developed and disseminated over 70 climate-smart maize varieties. He is a senior breeder who has contributed greatly to collection of germplasm and sharing knowledge across Africa. Welcome, Dr. Cosmos Magorokoso, ladies and gentlemen. Over to you, Dr. Cosmos.
Okay, thank you very much. I hope you can hear me.
Very well, sir.
Okay, I hope you can also see my screen. Can you see my screen?
Yes, yes, I can see your screen, sir.
Thank you very much. Okay,
welcome.
first of all, I would like to appreciate the organizers for asking me to talk about the future of food security with a bias towards plant breeding and biotechnology. I would like to acknowledge and appreciate the sponsors of the workshop, Forum, and the promoters. I'd like to also thank everybody who has taken their time to be with us. My name is Cosmos Magorokosho. I'm a plant breeder and I'm working for Innov Africa Genetics Private Limited, a new company in Zimbabwe. This is how I'm going to be going through my presentation. I think I was given 15 minutes. I will give a brief introduction and then talk about technologies that can accelerate plant breeding and biotechnology, technologies that I think work and can work in helping the issue of food security. And then I'll end with some conclusions. As a way of introduction, we've all heard about the issue of food security globally and in Africa. There are quite a number of issues. We have a rising population, not just in Africa, but worldwide. We have a global pandemic. We have the issue of the war in Ukraine, climate change, increased inflation, and all these are affecting food security in Africa. Just like was mentioned before, we have quite a number of millions of people who sleep every day without having adequate meals. However, Africa is 60% of the world's unused cropland, which means this can make a big difference in contributing to the food security on the continent. But plant breeding, biotechnology, and associated technologies are very crucial to make sure that we enhance productivity per unit area, not just expanding the area under cropping, because it is infinite and one day there will be a limit to that. So coming back to the topic that I've been asked to talk about, accelerating plant breeding and biotechnology to feed Africa, I just want to share a few tips of things that I think works. Number one, the root of all plant breeding is conventional breeding. It has been practiced since time immemorial on all the continents, and it has resulted in very impactful changes in the productivity, nutritious content of crops. Conventional breeding will never go away. It forms the basis for all new technologies that we can talk about in terms of enhancing plant breeding and biotechnology. So it will continue to play a role in the future, and it should not be underrated as we move towards resolving the issue of food insecurity in Africa. Everybody is aware of conventional breeding. This is a non-transgenic basket, that's what I mean. And this is the basis for what other technologies can be used to enhance plant breeding and biotechnology. One new technology that I've seen working, I think can work, and will have a major impact as we move forward, is marker-assisted breeding. This is simply the use of major genes or gene clusters in enhancing the efficiency of breeding, transferring a few major genes to varieties that we know already work, but lack a few genes or some gene clusters that will make them even better for food production and productivity. So marker-assisted selection is here. Genotyping costs are now very low. They keep going down each and every year. And I think that as we move forward, each and every breeding program should have some form of marker-assisted selection or genomic selection, or even both, because this enhances the efficiency of breeding. There are various forms of marker-assisted selection. There's marker-assisted recurrent selection, marker-assisted back crossing, and even symbol marker-assisted selection. This has been instrumental in improving simply inherited traits, but that are of major importance. We have used marker-assisted selection in introducing maize lethal necrosis tolerance to maize in East Africa. This problem came in 2011, and within a few years, by applying marker-assisted selection at CIMMYT, we were able to come up with new varieties that are tolerant to the disease. As a result, maize production and productivity has been maintained or has improved on the continent, and it is going to keep improving. Genomic-based breeding, this is part of the future of breeding. As a continent, Africa, we should not shy away from these new technologies. They are developed in the other side of the world, but they've been proved to work. Basically, genomic selection is tracking the whole genome to make selection decisions. So in comparison to marker-assisted selection, in marker-assisted selection, you're tracking and moving a few genes or a few gene clusters. But with genomic selection, you are making your decision based on the genome complement of your population. It is increasingly becoming important in breeding, especially for quantitative inherited traits, things like drought tolerance, things like heat stress tolerance, things like nitrogen use efficiency, and the like. The private sector in the developed world has been implementing this for quite a number of years, and it has been proven to be successful. It has also been applied to make decisions to increase the efficiency of testing. With genomic selection these days, you are able to decide things not to test further because you already know from the genome complement that they are not going to be good. Their probability of succeeding is very low. So you can use genomic selection to decide what to test rather than trying to test everything across many different locations, many different environments, and then encountering major costs. Genomic selection these days, again, is not implemented on its own, but it is combined with other technologies such as double haploid breeding or even incomplete block testing. All these are tools to reduce the cost, thereby increasing the efficiency and making sure that breeding decisions that are made by the breeders, they are the best. So you can use genomic selection in your breeding programs. It is not very expensive, again, because the cost of genotyping is going down each and every year. The use of doubled haploids, this is to accelerate breeding. Basically, you are generating homozygous materials within a few generations. In most breeding programs, you do some kind of inbreeding. It takes a long time, sometimes 6-7 years, to come up with homozygous materials that you want to test to decide which one is good. But with the use of doubled haploids, you can quickly get to homozygosity, lines that are uniform and can immediately be used for breeding within a period of, say, 2 years compared to the 6-7 years that is happening in maize. However, this technology is not just used in maize, but it can also be used in vegetable crops. I've seen it being used in rice in other parts of the world, and I think that in wheat, they are also using that. So there's a lot of opportunity in Africa for us to adopt this technology of doubled haploid. It brings in efficiency, especially when you are working with hybrid crops. Sunflower is a major crop, and there are now efforts to use doubled haploids in breeding sunflowers. So this is a technology that can impact Africa. This is a technology that we can adopt quickly, and it can be combined with other methods. At the moment, the use of doubled haploids is limited to a few crops, like I know maize very well, they are using that. But even in maize, it's just a few service providers that are available on the continent. So this is an area that needs to be expanded. I think if there are people who are providing funds, donors, this is one way to impact breeding programs easily by reducing the amount of time breeders are used to develop varieties. So there's need to expand on the use of doubled haploids in Africa, not just to specific crops, but to many, many other crops. Mutation breeding has been silent for a while, but it is regaining importance. It is relatively cheap, and cost-effective to look for genetic variation that has been elusive in many places. I know here in Zimbabwe, in my country, it is being applied in some public breeding programs, some private breeding programs. They are trying to look for full armyworm tolerance, and they are using mutation breeding. We have yet to see the results, but it has been very promising from the experimental materials that we see. In other parts of the world, this has worked very well. I know in Pakistan, there's hundreds of varieties that are developed using mutation breeding. And the generation of mutants can simply be outsourced. You don't have to do it on your own. Just develop your breeding population, send it to a service provider. They will send you back mutants you can select to use in your breeding program very quickly, rather than going through the long processes of breeding. Statistics. This is an area that is usually underrated by breeders. They always think about it at the end of the experiment. But if breeders start implementing the newest techniques in statistics, experimental design, and modeling, they can increase their breeding efficiency dramatically without changing so many things. There are now modern experimental designs, incomplete block designs that are very, very efficient, more efficient than the routine breeding designs, such as randomized complete block design and the like. The analysis of genotypic data, again, can be combined with analysis of phenotypic data in modern statistical packages. There's a statistical package or a statistical program called R that is freely available that can be used by many breeding programs. There's lots and lots of tutorials. There's lots of training programs on increased statistical use, increased experimental designs, and this can have a big dramatic impact in breeding. It works. We need to move as we increase our breeding programs and change to more efficient designs, more better ways of looking at the same data, combining different kinds of data, genotypic data, climate data, environmental data, and the like to make decisions on breeding in a very, very short period of time. This can increase the turnover of our breeding programs. Precision phenotyping. In the past, we used to be taking and collecting all the data manually in our fields, in our experiments, but with the coming in of new tools, drones, etc., etc., there are now ways to increase the efficiency simply by increasing the turnover of data collection. It is cheaper to use new methods. It is cheaper to collect data using the new technologies, using drones and the associated technologies. So you can simply increase your data turnover, and you can make data-driven decisions based on that data as quickly as possible. So you don't have to have all the machines, the fancy machines that people talk about, the fancy tools that people talk about. In Africa, there are many service providers that are just doing it for you. So you don't invest in the equipment, you just acquire their services and get your data as fast as possible, which is even more affordable. So you can get your data as quickly as possible, very cheaply. Genetic engineering of transgenics, this has been controversial in many parts of Africa. There's lots of talk still about whether countries should adopt it or not, but we've already seen that it works in other parts of the world. It is working even in some countries here in Africa. South Africa has adopted it. They are using it for some crops, and they are going to keep using it according to what they are saying. So despite the controversy, the future is bright. There are a couple of potential adopters outside South Africa now. We know that in Nigeria, they are talking about GM cowpeas. In Ethiopia, they are talking about GM maize for full armyworm and things like that. So this is a technology that I think is coming. We shouldn't run away from it. We should give the policymakers the opportunity, yes, to scrutinize, to make sure it is working, it is good. But I think we need to catch up so that we are not always following behind as we are trying to reach our food security. So we have seen important traits such as fall armyworm being easily dealt with using the genetic engineering. Gene editing, a relatively new and very promising technique. I think this is going to be the game changer. Already countries like UK, Japan, they are beginning to agree to use it easily without going through the complicated legislations that are associated with GMO maize, GMO technology. So this is very promising. As Africa, as a continent, I think we should not be left behind. We should simply ride on the wave that is happening so that we get to our food security as soon as possible. So I really think that each and every breeder should start to think about it. There are many people who are starting to provide the service on the continent. There are groups working on different crops. And this is really something that I think is a game changer. Why it is very important also, if you see the way the health sector is galloping towards gene editing, then you can see that it's going to be accepted easily in many parts of the world. So it's a matter of convincing our policymakers, our legislators that this is non-transgenic, this can make a big difference. And almost all the major countries, national programs, the private sector, they're already riding on this. Each and every company is looking for partners for this gene editing. I know the CG Center, they are working behind the scenes again to do that. So let's not run away from this. Let's embrace this because it can be a game changer to our food security. We have again a host of other additives that can enhance the breeding and the biotechnology, and they work. We have seen it before. Mechanization and automation of breeding programs. These are low-hanging fruit. Labor costs are getting very, very high on the continent. We used to be called the continent of cheap labor, but in terms of breeding, the costs are going up each and every day. Breeding is becoming a bit more expensive, but with mechanization and automation of breeding operations, we can also enhance the efficiency of the breeding programs as we gallop towards our food security. Again, with other additives, you don't have to do everything in breeding. You can outsource a lot of the aspects. You can simply become a hub. You outsource your phenotyping, you outsource your mechanization, your automation. You just get your data, put it together, you look at your materials, and then you make your breeding decision. So this is a means of combining technologies. You don't have to stick to one technology. If you have a breeding pipeline, don't look just towards one technology and say, this is going to make a big difference. Combining the technologies is the future. Again, as we are breeding, we need to look towards the future. There are problems that we already know are coming. I think we were very late in trying to breed for issues that arise because of climate change, drought, heat, floods, waterlogging, and the like. Climate change has been talked about for a long time, but really nobody was doing much. So at this juncture, I think that young breeders operating in the space should not just look at the traits that are a problem at the moment, but they should look to the future and say, in the next couple of years, what's going to be the issue? How can we preemptively breed for that before it becomes an issue? We have in maize, in the US, if people are tracking what is happening in the maize, in the corn, they call it corn. There is the issue of tail spot complex. It's a new disease that is coming to the US. 2 years ago, it was almost non-existent, but each and every year, it is increasing in the US and it's becoming a concern. It's causing yield reduction. So why not in Africa, we start preemptively breeding for that as we are breeding for our other traits. So I think that this is one way to make sure that if we have those shocks in future, we are already ready for them. We have solutions already. So we can actually stabilize our food security rather than to start to breed when a problem is happening. Finally, tracking genetic progress. We should not be breeding in the blind. We should know where we are. We should know where we came from. We should know where we are in terms of genetic progress, and we should actually predict and work towards the targets. We should not be breeding without targets. So this is tracking genetic gain, genetic progress as we are doing our breeding. So this is my short discussion. So in conclusion, I think that we all know the impact of climate change. We all know the impacts of the increasing and growing African population. We know the challenges associated with food security. We are still ways behind, but we have the potential to be a major player in the food networks and relieve a lot of stress on the global food security. So if we adopt as many techniques as possible, depending on the crop, depending on the scenario, depending on the resources, I think we can make it in making sure that Africa reaches zero hunger in the next few years. I think it's possible. I'm seeing that happening here in Zimbabwe. In the last few years ago, we were importing a lot of maize, but I think right now we are even producing maize that is more than what a country can use for food security. So it's possible. We just need to remain focused. We just need to run with the technologies. We just need to learn as we are coming from behind. We learn from other continents, but we need to run with the technologies to breed better crops, crops that are more productive and that can sustain and stand the changing climate. So with that, thank you very much. I'll take you back to the moderator. Thank you.
Thank you very much. Thank you very much, Dr. Cosmos, for those wonderful ideas about how we can use plant breeding approaches to be able to enhance productivity of the farming systems and contribute to a food secure Sub-Saharan Africa. Ladies and gentlemen, it is a pleasure once again to have you hosted in our first webinar series under What Works theme, the future of food security in Sub-Saharan Africa. Next, we will have a presentation from Dr. James Mororo. Dr. James Mororo is a scientist with ICRISAT in Eastern Southern Africa region. He is a specialized groundnut breeder who has developed a number of resilient groundnut varieties. He has a PhD of plant breeding from Makerere University. Dr. James has contributed to supervision and training of many masters and PhD students, skilling the next generation for food security in Africa. Ladies and gentlemen, welcome with me, Dr. James Mororo, to make his presentation on genomics in Africa, present and future prospects. Thank you very much.
Thank you, the moderator, for the opportunity. Also, I take this opportunity to thank the Forum for organizing this webinar and inviting me to be one of the presenters. Highly appreciated as we work together towards ensuring that we have a food secure Africa. Due to my internet challenge, I'll switch off the video, so you will bear with me. So colleagues, ladies and gentlemen, I take this opportunity to share a few thoughts with you in relation to genomics in Africa. Take his talk of what has been done, where we are, and try to articulate a bit about the future. So I'll try to be short and to the point so that we move with speed. Yeah, as a context, Africa is facing a perfect storm, given the challenges which my predecessor Cosmos has highlighted, the issues of climate change, increasing food in demand, increasing population, as well as pandemics, as we had the recent COVID-19. And this means that we need to move with the speed so that we can ensure that there is supply of quality foods to meet the looming demand by rising populations amidst these challenges. And the genomics that focuses on trying to associate gene functions to key traits of importance is one of the approaches that we can be able to harness and integrate within our breeding systems, within our operations, to ensure that we have efficiency as well as effectiveness to deliver quality products within the shortest time possible. The field of genomics has opened up an array of opportunities, and this can be harnessed to ensure that we have enhanced crop productivity in the face of climate change, for example, in the face of new diseases, as well as emerging effects. And this will translate to increased prosperity of our farmers, producers, and consumers, due to the fact that we'll have adequate supplies of food, and at the same time, food that is affordable, and at the same time of high quality, thereby alleviating poverty as well as malnutrition in Africa. Integrated within genomics is the aspects or tools such as plant bioinformatics and artificial intelligence, which has tried to give more insights into the genetics of the crops so that we can be able to model our crops, develop our varieties, our products, by ensuring that we focus on the key traits that are of importance in the market and of high preference to the consumers. The current status of genomics in Africa. The revolution of genomics in Africa was enhanced by the development of the next generation sequencing technology that has enabled the sequencing as well as assembly and annotation of key African plant genomes. And as we speak, currently we have a total of 13 African plant genomes that has been sequenced. And this is an asset for our African-based partners as well as African-based groups and the research to harness this technology and ensure that we accelerate our breeding programs and then deliver quality products within the shortest time possible. At the same time, Cosmos also highlighted the aspect of gene entity, whereby over the years, over time within Africa, a number of varieties, you see these technologies. For example, the case of Ndrotoreland, rice varieties, nutritional attributes in cassava, as well as the African cereals genomes that have been sequenced, and also apply the same to legumes such as chickpea, groundnut, as well as soybean. So with this technology, again, we have been able to model and come up with quality products, which in the near future is going to bring a tremendous impact in relation to food and nutrition security. In addition, there is the emerging high-end genomic technologies that can further be expanded and contribute to medicinal plants, thus also contributing to the health sector because these different fields, health, agriculture, are all intertwined and they cannot be addressed in isolation. So again, using genomics, we can go and contribute much further to health aspects. However, despite some of these kind of achievements or tremendous progress, you will find that there are still some challenges within the African context, whereby there is lack of awareness of the importance of genomics in improving breeding techniques, as well as contributing to agriculture and the food security in general. Lack of African scientists or limited number of scientists who are able to drive the genomic science forward, as well as limited infrastructure, minimal availability of computational expertise and the tools, so that within Africa, that accelerated change due to this technology genomics can be felt. At the same time, limited sufficient funding for research activities from African governments and the involvement of African researchers in partnership research. Because for us to be able to move ahead and achieve so much, to be able to address the different disciplines across the genome, transcriptome, proteome, metabolism, as well as harnessing this technology to ensure that we deliver, it needs a pool of resources and ensuring that in different regions, for example, at least there is a facility that is available and it can be able to support the breeding efforts to deliver these products. What I say as pathway to scale is what do we need so that we can be able to accelerate these efforts? So for example, coming up with the genomic networks platforms that can be used as avenues for training, building capacity, whereby all these needs coordinated efforts among the higher education institutes as well as agricultural research centers in the specific countries, as well as international agricultural centers and donors working collectively together so that we ensure that these facilities, these technologies, this knowledge is available within the vicinity of Africa at large. Then government policy that favors the investment in genomics research as well as supporting its applications. Then also working through collaborations, for example, the Pan-African Plant Genome is one network or consortium that coordinates broad interests of the plant genomic community. So if we can have more of these kind of people who are focusing on the same agenda to be able to deliver more. Then acquisition of expertise and the facilities necessarily to lead high quality plant genomics research is key, so that again, we can be able to address the key emerging challenges in the region to ensure that we move with speed and then deliver high quality products, high yield varieties, disease-resistant materials, high nutritious crops to address the aspect of food as well as nutrition security. So all these means those coordinated efforts as well as the willingness from the different counterparts to ensure that we move collectively together, we work together, and be able to deliver as a team. The future prospects achieve or harness this genomics technology, be able to address the food insecurity as well as our national governments, regional, political, as well as economic organizations have these efforts towards ensuring that we have available funds to support the plant genomics research, as well as ensure that the facilities, the infrastructure is available. Then enhance policy. So policy for Africa, for example, to ensure that within the different African countries, we can be able to exchange knowledge, exchange facilities, exchange materials to ensure that we move together and then deliver as a whole. Then ethics, also ethical and the social implications of plant genomics studies, outputs, products should be considered and ensure that they are well integrated in the different, in the laws of the different countries to ensure that the environment is favorable for this technology to thrive. Then awareness and the targeting to ensure that our policymakers are fully informed so that once products are being delivered using these different technologies, biotechnological tools, for example, are well received and adopted to ensure that we deliver and ensure that in the long run, they are not facing resistance. Then also ensuring that measures and the targeted action is taken to ensure that Africa does not miss from the plant genomics revolution. So we are somewhere, but we still need more efforts to ensure that at least we are achieving maximum benefits out of these technologies. Then finally, continuous innovation and the collaboration is key. For this is going to shape the future of our agriculture, food safety, as well as nutrition in Africa, translating into enhanced productivity, for example, enhanced food available on the table, enhanced incomes of our producers as well as growers, as well as availing of nutritious products, foods to our populations in the long run. So in a nutshell, that's what I wanted to share with you, so that together we continue moving together as a team and be able to deliver. Over to you, moderator.
Thank you very much, Dr. James, for that wonderful presentation on plant genomics in Africa, present and prospects for improved food security for Sub-Saharan Africa. Ladies and gentlemen, next we shall have a presentation from Dr. Frank Kumi. titled Trends in Crop Improvement of Underutilized Crops. Dr. Frank is a lecturer of plant breeding and biotechnology at the Department of Crop Science, the University of Cape Coast, Ghana. He holds a Master's of Science in Virology, and he has a lot of experience spanning 12 years in plant biotechnology, quantitative genetics, and bioinformatics. Dr. Frank Kumi, you are most welcome to make your presentation.
Good afternoon to all the various audiences that we have from every part of the world. And thank you for this wonderful opportunity given to me. To the Referrum Network and Fraternity, it is a joy to share knowledge with up-and-coming scientists, people who are already stakeholders when it comes to science and contributing knowledge to the entire world. My presentation will focus on the trends in crop improvement and with specific emphasis on underutilized crops. I'll give a brief overview with regards to the production trends and the challenges that beset us in Sub-Saharan Africa. The current development of climate resilient varieties through conventional approaches where we do hybridization and selection is plagued with issues with input intensiveness with regards to labor, land, and time, which are very scarce resources. And therefore, it limits the realization of the genetic gains that we normally get from the crops that are being consumed in Africa. Developing any short-term improvement program to tackle food security in Sub-Sahara will need very robust methods that would curtail issues about modification. Also, looking at both qualitative and quantitative outcomes with regards to transgenics or deploying conventional breeding schemes as well. The projected population of Sub-Saharan Africa is in excess of 1.18 billion. And as it stands, Africa has the highest reproduction rates. It tells us that there is a need for us to be food secure, and we cannot mitigate the issues about food security or food insecurity when it comes to using conventional means of breeding to feed the ever increasing population in Sub-Saharan Africa. There has been several breeding centers which focuses on underutilized crops, and they work in partnership with already known agencies or centers which we are more familiar with. As examples are, we have the IITA and ICRISAT, which are into rigorous and intensive research with regards to tackling the issues about food security in Africa. It must also interest you to know that when it comes to underutilized crops, centers or agencies or organizations have been set up with key mandates tackling issues about conservation, issues about diversity, and as well as making resilient or developing plant varieties that will help solve the ever increasing population in Africa. I'll mention a notable examples in this particular presentation. The first one has to do with the International Center for Underutilized Crops, which is also abbreviated as ICUC. It was established in 1992 and it is being headquartered in Sri Lanka. We also have the Crops for the Future, which is CFF, which was established in 2009, headquartered in Malaysia, and it is being jointly hosted by the CGR partnership in consultation with the University of Malaysia, Nottingham campus. There is also the Convention on Biological Diversity, which is CBD. It was established in 1993 and it is headquartered in Brazil. Last but not the least, there is the Global Facilitation Unit for Underutilized Species, which is also abbreviated as GFCU. It was established in 2004 and is headquartered in Italy. All these centers I've mentioned have been mandated to see to it that there is a close collaboration, or they are mandated to ensure that underutilized crops are well utilized and harnessed so that they will become more available to be able to compete with already staple crops that we have. So they work in partnership with already established regional and local agencies who are mandated to ensure that food security is attained. Crop improvements on underutilized crops are very important areas, and they are received research gains, which offers potential to increase their productivity, diversity, and also resilience to the agricultural system, where climate change happens to be the very bottleneck that must be tackled. But particularly in Sub-Saharan Africa, where we have population in excess of 1 billion, the issues that relates to food security, climate change, biodiversity conservation is highly unpredictable, and the impact that it poses to us is highly unquantifiable. Therefore, there is a mandate for us to make sure that all the available tools and resources that can help us mitigate the challenges of what food security is utilized. I'll handle or tackle some few breeding trends with regards to solving the issues about food insecurity when it comes to breeding trends. First on the list is the next generation sequencing, also abbreviated as SGS. It is currently the most cost-effective improvement strategy that can be deployed to enhance the genetics of crops in general, but key emphasis here has to do with underutilized crops. And over the last few decades, there has been tremendous and significant changes on the pace at which genomics, transcriptomics, and proteomics have been used when it comes to enhancing underutilized crops. Currently, this technology has been able to offer us the ability to generate sequences of plant genomes from different species in 1,000-fold or even more. Hitherto, the tools that we're using to assess or collate these data was very limited, but genomic next generation sequencing has made it very accessible and easy for us to study these molecular approaches. Next generation sequencing also offers a high throughput technologies where we study proteomics and also transcriptomics to be able to understand traits that are being imbibed or embedded in plants. And for that reason, we are able to locate their position in the loci for us to be able to deploy them for efficient use. In this way, there is a shift from working in single species in isolation to the holistic approach of working in complexes where we can both adapt wild relatives to improve on them to domesticate them as a whole. This slide shows the various steps that are being engaged or deployed when it comes to next generation sequencing. The DNA or RNA genomic material is extracted in step 1. Then libraries are created with it with regards to the fragment of the DNA or the RNA that was isolated. They are further subjected to sequencing for us to know the arrangement of the nucleotides with regards to deconferring or detecting a particular trait of interest. They are therefore curated or stored in platforms that can be extracted to make meaningful analysis with regards to breeding technologies. These platforms or next generation sequencing approach has also offered the advent of notable bioinformatics softwares or tools that can be used to analyze this biological data, which is blunt data, for us to make informed decisions in our breeding approaches. I'll just highlight on 10 key bioinformatics softwares that can be used to analyze this sequence data. We have the Strand NGS, we have the CLC Genomic Workbench, we have the DNA Nexus, Ingenuity Variant Analysis, we have the Laser Genomics to We have the NextGen, Patek Flow, Golden Helix, where we use SNPs and variations suites to be able to access such data. We also have the genomatics and as well as biodatanomics. These are commercial softwares and they must be bought to be able to access them. However, there are freeware internet-based bioinformatic websites where we can easily make next generation sequencing or sequence data available for use. And key among them is NCBI database, which can easily be used to make meaningful analysis, to be able to understand what traits are there in particular underutilized crops and how best these traits can be utilized and introgress into other crops. Second on the list with regards to the breeding trend is genomic selection. I think my previous speakers highlighted on this area, and I wouldn't spend much time with genomic selection. Marker-assisted selection hitherto was the goal of the day, but there has been an improved version of marker-assisted selection where this time around we are sequencing, or we have mapped the whole genome of a plant, and they are associated with specific QTLs that must be deployed or harnessed for us to be able to work on these underutilized crops. So though marker-assisted selection has proven its potential for improvement on qualitative traits, controlling monogenes, there are issues about, with their effects being large, there are issues about polygenic traits, which also affect expression of certain key traits that are in plants. For that reason, there was a need for us to be able to more or less calibrate or find a more robust approach in understanding polygenes controlling certain traits. And with regards to that, under climate change issues, we are talking about traits such as heat stress, nutritional traits, which are not easily identifiable when you use mass. However, genomic selection will help you understand these traits better for you to be able to make informed breeding program and decisions. So genetic selection uses genomic estimated breeding values, also abbreviated as GEBV, of individuals which are obtained from a genome-wide markers for potential of being candidate genes that can be used for a breeding cycle. And I have this slide to explain briefly what this entails. In using this particular breeding system, we have what we call a training population. And by this training population, we mean a population that has its individuals already phenotyped and genotyped. So we have, let's say, germplasm, but these germplasm have already been phenotyped or genotyped. So we already know what their breeding values are. Then we have our breeding population, which can also be genotyped for us to understand what actually happens at the genetic level. The training population that has already been phenotyped and genotyped is subjected to a model, which we call the genetic or genomic selection model training using estimates so that we can be able to predict their genetic estimated breeding values. Combining the genetic estimated breeding values from the training population and the already existing breeding population, we can come out to have a selected population that can be well advanced to be able to have the traits the traits of interest that must be further on be advanced. For genomic estimated breeding values, we don't look at effects which are associated with only the environment. We also go ahead to find out at the genomic levels which variations exist. And in so doing, the estimation of the genetic breeding values, we don't leave out the environmental effect as well. Genetic or genomic selection approach was first adapted and utilized in animals for animal breeding, but this method has so far been adopted in plants as well. And it helps us get It minimizes the stress that we go through when it comes to phenotyping. It reduces the breeding cycle as well, and it increases genetic gains. Significant evaluation outcomes through genomic selection have also led to the improvement of yield, biotic and abiotic stresses with regards to heat, and also some qualitative traits such as the oil content and improving the shelf life of certain underutilized crops. This method has been used extensively in crops like wheat, barley, maize, and rice, and can therefore be adopted for underutilized crops. There is also the genetic engineering or gene editing approach. And my focus on this particular one has to do with using CRISPR technology for Cas9. It is currently the most widely used approach for genome editing, and it is based on the clustered, regularly interspaced short palindromic repeats, which is associated with a protein called Cas9. This technology has been modified in order to create a versatile genome editing technology for understanding or studying the diversity that exists among certain species. And it has been applied extensively in agric, and notable amongst them is in crops. And basic gene functions have been studied. I'll give examples of certain notable crops that this technology has been used or worked on. Simply, the technology seems to isolate or restrict key loci or regions in the genome where certain genes or certain traits are of importance. And by this, we use endonuclease, which are proteins. They are naturally occurring in bacteria and certain algae, and therefore they can be used in modification or created artificially to be able to effect or modify some of these improvements that we see. CRISPR technology has been used to develop disease-resistant varieties in crops. We now have crops that are able to withstand biotic and abiotic stresses. We have plants that are able to fruit and give you quality traits. We also have plants that are able to flower and fruit with a peculiar pigmentation that is needed. We've been able to modify the juvenile or the longevity of certain crops with regards to editing their genome. There is also what we call the flower longevity and the improvement in the fruits and the berry shelf life. All this encompass what CRISPR technology is. Initially, the technology was very expensive, but now other tools have been made accessible, so they can easily be adopted. And in Sub-Saharan Africa, this is the time for us to adopt such technologies. The CRISPR technology has been used to enhance yield and certain qualitative traits, as earlier on mentioned, with regards to shelf life, the taste of certain crops, with regards to their fruits and stuff. Peculiar pigmentations that we need in certain crops can also be done. We now have sweet pepper, or someone would say bell pepper varieties that are green, some are yellow, even purplish. With regards to gene editing, this can be done. Nutritional values have been improving certain crops in Africa, where malnutrition is a very key issue, and therefore it must be worked on. To introduce or enhance tolerance of crops to biotic and abiotic stresses, where some abiotic stresses has led to famine in some parts of Africa, there is a need for us to harness such technologies to be able to mitigate these challenges. So we're now talking about breeding for cereals that are able to withstand droughts or under limited moisture availability. CRISPR technology has been able to accelerate plant breeding, and it has made the process more predictable, and therefore it allows for us to create more genetic diversity with regards to certain underutilized crops. I would spend some few time to highlight on some current breeding works that are being done in CGI centers, which are in Africa, and they are currently at various stages of modification or various stages of development when it comes to this crop. So with banana, there is a gene that has been able to be infused or edited in banana, and they've been able to develop disease-resistant banana varieties. Peculiar amongst them is now banana varieties that are resistant to banana xanthomonas wilt. We also have banana varieties that are resistant to fusarium wilt. We also have cassava varieties where respective genes called the sweet gene promoters has been modified, and we've been able to get resistant varieties of banana with regards to that. We also have cassava that, in terms of food safety, it is cyanide-free. The cyanide content has been eliminated to appreciably low levels, and it was as a result of editing a gene which was involved in linamarin synthesis. When it comes to maize, now we have maize varieties that has weed resistance. And with regards to a particular weed, we are talking about striga. And a gene that is involved in this resistance was the strigolactin. And currently it is at the stage of 3, and stage 3 in the slide that I've given is where we have early development. So it's still at the early development stage. For potato, we currently have disease-resistant Irish potato varieties to potato virus Y and also late blight disease. In rice, we have rice varieties that are resistant to the late blight, rice varieties that have low arsenic and cadmium levels, and rice varieties that are able to utilize and remobilize nitrogen in the soil. And they also have insect resistance as well. I would like to thank the audience and all the various people who have joined from various parts of the world for listening in to this presentation. Thank you very much for the audience.
Thank you very much, Dr. Frank. Thank you very much, Dr. Frank, for your wonderful presentation on the trends in crop improvement for underutilized crops in Sub-Saharan Africa. Your presentation was wonderful. It raised a number of insights into what has been achieved in Sub-Saharan Africa, but also what can be used to accelerate breeding and genetic gains for feeding Africa. Ladies and gentlemen, it's my pleasure to welcome Dr. Prosi Isibikaru. Dr. Prosi Isibikaru is an associate professor at Makerere University, and she will be making a presentation making participatory plant breeding inclusive for Africa. Dr. Prosi Isibikaru works at the Department of Agriculture Extension and Innovation Studies at Makerere University, and she holds a PhD in social sciences from Wageningen University in the Netherlands. And she has trained, supervised, and mentored many researchers, both at master's and PhD. And she has a lot of experience in participatory approaches, in rural sociology, in community development initiatives. I want to welcome Dr. Prosi to make her presentation.
Thank you very much, Chairperson, fellow panelists, organizers, ladies and gentlemen online. Allow me present behind the camera, apparently because the internet here is unstable and probably others could be having that unstable one. And maybe just for those who don't know how I look like, this is Prosi, and I'll be working behind the camera. Okay. Yes, the concept of participation. We are thinking of how do we make participatory plant breeding inclusive, because already when we talk about participatory plant breeding, the essence of participation is there. But I need to remind ourselves that for sure, sometimes we get lost because we use the word participation differently, and yet we want to benefit something different. Participation is used differently and largely as defined by the outsider. And in this case, the outsider is us, me and you, who goes to engage the different actors because we want to realize some objective. So we define what participation will be, and sometimes it is maybe not the right way to define and use it. And as in plant breeding, how do we define and how do we use participation? Because it is a concept, and most of the time it is used with a dichotomy kind of thinking where you have either or, either or, either or. For example, are we using participation as a means to accomplish our aims effectively, efficiently, or cheaply, or are we using it and seeing it as an end in itself? Are we seeing it as a way of actively involving all that are affected, or are we using it just to make them sit and listen to what we are saying? In activeness, are we making everybody part of the agenda setting, or are we saying others should just wait and we set the agenda for them? Are we seeing it as a tool, or are we seeing it as a process? Do we encourage the bottom-up approach, or we only look at the top-bottom? Do we use participation in a constructive way that benefits every player there, including us, or are we using participation to exploit, especially the people we claim to be engaging and working with or for? So those are all questions that we need to think about. But still, we want to think through how do we make participatory plant breeding inclusive? In other words, how do we make the participation inclusive? How do we make sure that people are really on board and the ones that want to work with, and the ones that count, the ones that contribute to the solution that we want to get? I will share with you a few insights that I developed. One is, we need to reflect on who the actors are. Do we identify the right actors? Do we engage them? And do we select the right ones? Because identifying and selecting are two different things. And do we actually go ahead and bring them on board? Do we mobilize them? What mobilization methods do we use? Do we only use email, for example? Because how sure are you that the other person got the email and understood the message you had? Who are the actors in the field? Do we know them? Some of them we know them, some of them we don't know them. But we will know them when we start by the activities and processes that we need to accomplish right from the beginning to the end. Remember that breeding is never completed without its product being used or being visible. So who is contributing to this new plant being used right from the beginning to the end? Are we engaging them? How best do we get them interested and willing? Because identifying and selecting them is one thing, but keeping them interested and willing is another thing. Do we take that extra time? Sometimes we are too busy and occupied and we feel that, well, they should be interested anyway. But remember, it is us who want to be felt by our product. How do we get the other actors interested and willing to be part of the journey? Do we use a mix of communication styles? Because remember, we are dealing with people and we're producing for these people. Do they know what is going on? Do they understand what is going on? We use different mix of communication styles, but remember, face-to-face is always the one that gives the warmth, that makes a person really understand what you're saying. Do we use it? Or even, especially when we have the chance, or we also hide from it? Number two, we need to re-engage. The first one was you are identifying, mobilizing, and letting them know that there's this other problem that you and I can work on to solve. But number two is saying we need to now re-engage, bring all these people that you have been able to identify and select in a meeting setup. It can be a workshop face-to-face, or if you're going to be using virtual, I know virtual sometimes has its limitations, but it also has the advantages. But the most important reason is to get them to have a collective direction. Give them chance to know each other, because really, if you don't know people that you're working with, chances are that you're going to keep to yourself some other things. And you're going to also limit your interaction. Yet the interaction is what is going to show who is more competent, who can produce this, who can provide this information, who can play which role. And in that re-engagement, you'll be able to get more other actors who you'll have excluded, so to speak. Because sometimes we only go with the ones we are used to working with, and we tend to forget those that we have not worked with for some reasons. We want to re-echo the problem. Do we all share the same way of understanding the problem? Or is everybody understanding the problem differently? If we all have the same way of understanding the problem, chances of working together to make sure that this problem is solved are very high. But if the problem turns into many problems, which are not shared, which are not common, in others, everybody seems to be addressing a different problem, then there's going to be a problem there. So we need to re-engage people and make sure that we all have a common understanding of the problem that we all want to work on. Because we want to work collectively, interdependently, and our efforts must be complementary in solving that problem. Do we have a common objective? Yes, when there's a problem, do we all agree on a common objective that we want to realize at the end of that day, so that all our efforts are being directed by this common objective towards solving that problem, although we shall be playing different roles? Do we have an agreed number or types of strategies that we are going to use to address that problem? Do we all agree that these are the strategies and we know how we are going to play them? Do we have clear roles and responsibilities? Sometimes the roles and responsibilities are what we know people do. For example, Makere, it is teaching and research. But when you look at the problem on the floor, Makere can play more roles than teaching. So sometimes we need to redefine and clarify the roles and responsibilities of each actor. And this has to be done collectively, because you don't want to assign a responsibility to someone who is not there and who doesn't know why you are assigning such a responsibility, and also how they will even play that role. We need to develop and make use of a mechanism. You develop a mechanism and make use of it that will support every actor. Remember, we are coming together to work together, to solve a problem together that we are feeling should be worked on. There has to be a mechanism that makes every one of us feel supported and actually be supported to actively play our roles and responsibilities. Do we provide all information that is needed to every person that needs that information that will make them be in a better position to play their role? Or we tend to hide some information, like it happens. Build capacity where it's needed. Do we know where a specific actor who is on board is weak, and we can help to build their capacity or to show them how to build their capacity? Do we appreciate them? Do we recognize their efforts? Imagine you're playing a role and no one seems to be appreciating what you're doing, your time, your resources. Would you want to be part of that game? Instead, you look at them and stay on the fence. But here we're saying everybody should come at the center of the football pitch. Do you value them and their ideas and their contributions? Or you only value their contributions and not their ideas? You need to value them as people and their contributions. We need to create an environment that encourages and allows frequent interactions. How shall we know each other and accept to work with each other and share what we have when we do not know each other? When we do not interact? Do we even create moments of interaction? Do we interact around many things, around money, around machines, around equipment, around jumplasm, but the players in this, are we getting the environment that is giving us chance to interact? And do we actually give ourselves permission to interact, or we get some barriers and excuses? When we do frequent interactions, it will ask us to know each other, not only by name, competence, weakness, resource. Who is this person? When I say person, for example, I would be referring to an organization. Remember, an organization will be identified, but from that organization, they will identify the actual person that will be working with. That also takes a process anyway. We need to build interdependence and team spirit, because the moment we know each other, we will know how to help each other, and we shall know how the other person fits into my work. We'll be able to share and provide personal feedback. Personal feedback is very important, which we almost forget. Remember, we are human beings. And when you err as a human being, chances of what you do, chances of people taking what you do as wrong will be very high. And yet it is not the things that you're doing, but it is you who is having a problem. So once you provide personal feedback, we can reposition ourselves to be more useful to each other. We'll be able to build trust, and consequently build and step up more and more interactions that are constructive and will lead us to solving that problem that we are sharing. We need to make actor participation enjoyable. Really, you can be part of a game, part of a project, part of a system. Yes, because you are supposed to be there by design, yeah. But you are not enjoying to be part of it, so you remain passive. We need to make actor participation enjoyable, and this will sustain interest and commitment. You don't want to start something and then people just pull out. And they start saying, it is their thing, it's not our thing, it is their thing. You want people to enjoy and identify with whatever comes even within the process. So inclusion of the concerned should focus both on the individual and the ideas. Do not just include one of them. It is the person and their ideas. This will support individuals to feel connected and valued. And therefore, we need to address any forms of social exclusion that may come across. There are many factors that can give birth to this exclusion. Sometimes we say these ones are poor, these ones are not poor. I mean, that in itself is excluding. These ones have, these ones don't have. But let us go by role, not by possession, because we want them to be part of us, irrespective of the role they are playing. Remember, we are looking at the chain, the entire chain of plant breeding, starting from identifying the germplasm and where it's going to be multiplied from, how it's going to be mixed up to where it's going to come out as this variety. Motivation of engagement and interaction is very important, because the moment you're dealing with human beings to work on a problem, they need to be motivated. Their engagement and interaction has to be high. They need to have meaning for engagement. Why am I being part of this? Am I making sense? Do I get sense out of it? Not just putting someone there because because Makerere does this, for example, or Naro does this, but it's beyond that. We need to help each other develop the right attitude of working together. When we work together, we know that we have different personalities, yes, but even attitudes will crop in. How do we help ourselves in this system, in this program, in this activity, in this process to develop and use the right attitude? Because that is when we shall work interdependently and support each other. It's good to ensure all the groups of actors, irrespective of race or ethnicity, or any other factor that may create exclusion, the exclusion part is dealt with. These people should all have meaningful voice. In others, they should all contribute to the agenda. Give them chance to contribute to the agenda, and you can't just paraphrase. But many times when your ideas are left out as a contributor, you don't see why you should be part of that game. We need to improve the terms of participation. Give all actors that are concerned an equal chance to participate. And participation is not only being present and sitting. Participation is also contributing in a way, either information or questions or methods or equipment. I mean, let it be known what is it that we are taking as participation. Promote equality of opportunities. Let people have the same chances of utilizing and providing what they have. Now, this nails back the social inclusion as a process. Let us look at inclusion as a process, as an outcome, and as a practice. We expect it to be something that's part of us over and over. It is not something that we just want to use as a means only, but do we see people even making a proactive decision to be part of us? Are we seeing ourselves stretching our hands to make it a practice that we engage all, irrespective of the boundaries that are likely to make them excluded or marginalized. Embrace participatory plant breeding as an agriculture innovation system. In an agriculture innovation system, different actors with different experiences, competencies, knowledge base, resources, name it, get together, they share their knowledge, definitely they have different bases of knowledge, ideas, opinions, technologies, name them, to solve that common problem collectively, because now everybody identifies that problem and is interested actually to solve that problem and will use what they have to make sure that they contribute to solving that problem. They work together to solve that problem. And for the agriculture innovation system, which now I'm looking at as an example given by the participatory plant breeding, because even in participatory plant breeding, there are different actors. I've been hearing people speaking about software engineers, all those people that play a part, play a role that makes plant breeding felt by the product. So in agriculture innovation system, we need these to function as the main pillars. The actors, all the actors that are affected should be part of it, and we should make effort to bring them on board. They may not be all brought on board at the same time, but depending on the different activity that needs them. Remember, all actors affect the rate and direction of what will come out, and we need to have them on board, and we need to work with them, and we need to make sure that we help each other to get the right direction of what we want to come out with. Encourage effective interactions. The word is effective because they have to come out with a solution. They have to come out with something which is tangible that is moving towards solving that problem. We don't have to forget the institutions, the mandates, the policies that guide these people, because they come into play. But also when you're functioning as a collective, as a family, as an agriculture innovation system, maybe the institutions that will guide your activities, your interactions are going to be different from the institutions where you come from the policies that guide you. Because just imagine you are coming from different families and forming a marriage. The rules that used to work in your individual families may not be the rules that will function in your new marriage. So you have to come up with new rules that each of you identify with and encourage that interaction and peaceful collective action. Infrastructure too has to be functioning. Any failure of this is likely to cause a system failure. We have heard about system failures in human beings. Let us borrow it into this. If participatory plant breeding is looked at as a system and agriculture innovation system, any component in any of these areas that fails will fail the entire system, because it is borrowing from a systems perspective where a big system is formed of smaller systems that are functioning. Look at a system like a human being. The whole human being is a system. But we have smaller systems that are running to make us alive. You're technical scientists, so you have these examples: the blood, the respiratory system, the threshold system, the digestive system. Let one of them fail, or one of the organ or a component of it fail. Chances are that it is going to spread to the entire body of the person, and we are likely to miss that person. So we are saying, for any factor that's likely to fail any of these, we need to collectively identify it and address it. Okay, so some of the silent issues that we need to think about when we are thinking of innovation and that new variety of plant as our innovation. Let's think about, what is the problem? Is it very clear to all of us? Does that problem require us to work together? Because some problems probably may not require collective action. But if that problem requires collective action, then yes, let us feel it. Then we have to be very clear, whose problem then is it that we are addressing? Because if we know whose problem it is, it's going to be very easy for us to know how best to come in. Remember, we all identify we are interdependent, but we need to know whose problem. If the problem, according to us, we are saying is for the farmer, then it is likely that we are not going to be as embedded. We shall just be working to please the farmer. But do we identify with this problem as us as well? Do we know that in solving this problem, chances of other new problems coming up are high? And we need to identify those likely new problems that are likely to crop up as a result of solving this other problem. We need to agree how do we plan to work on them. Or else people will start breaking themselves into saying, oh, it's a trouble causer. It is Uganda. It is narrow. It is, I mean, name the category of the actor that you're likely to blame. Remember, we're supposed to work together and minimize this. Likewise, we need to know who may be harmed, who actor category, who continent, who village, who, I don't know, name them. And how do we plan to handle that? Because if we don't handle that, chances of losing out our visibility are very high. Why do we ask these questions anyway? One, raising these questions is not meant to make the process complex or complicated. It's not to tell people, no, now don't start thinking of new things, no? It is to remind us to be sensitive to factors that are likely to render our new plant, that innovation abandoned in the long run. We have heard of situations where many things that you have put in a lot of money and time and brain, it has come out, but in the short run, people drop it. And then when people drop it, we look at those people as not serious. But at the end of the day, is it those people, are they missing anything? Or you are missing more than that? We want to minimize that because chances are high that it will happen. But can we minimize the presence of that? Given that innovation is a cumulative and evolutionary process, just like plant breeding is cumulative and evolutionary process, by the time you come to give us that new plant, we've gone through a lot. We need to be alert and proactive in improving the merits of the old plant. Let me use the word plant, because we are improving this plant into a better plant that is likely to be more effective and efficient in solving the food and income needs of Africa. But this new one, what are the demerits? Because we want to make it more efficient and minimize the negatives. Sometimes the negatives are inevitable, true, they're inevitable, but we need to know them and how we need to keep them at their lowest to minimize the rest of the actors who are not only the farmers. Remember, it is not only the farmers that are actors. I said every person is playing a role, because in playing their role, they are promoting the use and visibility of this. Okay, this was something just remind us about inclusion, but I can still jump because I've already mentioned it. But at the end of the day, why are we interested in having participation that is inclusive? Why do we want to make sure that every person that is concerned is part of us? We want to increase the ownership. You'll bear with me that you will want to own something where you have put a finger, where you have actually contributed to, and you don't want it to get destroyed. You keep saying our, because you know you have invested in it. So if we don't encourage you to invest in it, then chances of you not caring about it are very high. To build and maintain sustainability of what is working and the outcomes. What is working could be that plant. What is working could be a method. What is working could be a style. Plus what comes out of using that. We want to sustain them because there are things we want to move with. To encourage collective mobilization, we've talked about we've always said resources are limited, but different actors could be having access to different types and quantities of resources. Once they are in and part of the agenda, chances of identifying what they can bring as a resource and utilize or lend us are very high. But the moment they feel left out, they will hide their resources, name them, whether it's personnel, machine, vehicles, name it. And we also want to build capacity within ourselves. We should be able to do many things as we get along and build confidence among ourselves that yes, because we have done A and we have really realized the A, we are confident and we are going to raise our heads up to attack B, because B is our next problem to attack. And at the end of it all, we are all empowered. Not only one category of actor. We are all empowered. Everybody will know what to do and how to do it, and how to stand and stick their neck high. Thank you very much. I think I've used more time than I was given. Allow me end my conversation here. Chairman, back to you.
Thank you very much. Thank you very much, Dr. Prosi. Indeed, your presentation was very interesting and very challenging for the core breeders to see how we can bring on board the stakeholders so that our breeding indeed contributes to food security in Sub-Saharan Africa. Ladies and gentlemen, we have about 20 minutes to close, but I want to ask you to attend to the presentation by Dr. Baji Afang. Dr. Baji Afang will make a presentation on addressing African hidden hunger and equity. Dr. Afang is an assistant lecturer at Makerere Regional Center for Crop Improvement, Mercy, and he is a breeder. I want to take this pleasure to invite Dr. Baji to make his presentation. 10 minutes, please, Baji. And then we shall have 10 minutes of discussion and addressing the questions that have been raised by the participants, and we shall close the webinar this evening. Dr. Baji, you are welcome. Hello, Dr. Baji.
Good afternoon, everyone. I hope my slides are being seen.
Yes, go ahead, please.
Okay. I was given 15 minutes, now it is 10 minutes, yet even the 15 minutes I was doubting. So, I would like to take this opportunity to thank the Reforum and all the organizers for having invited me, for having organized this webinar and having invited me to make a talk. Moderator, thank you for the presentation and for the introduction. So I'm called Afam Baji. I'm a postdoc at Makerere University Center, Regional Center for Crop Improvement. And Makerere, I'm going to address you on addressing African hidden hunger and equity. So we noticed that the number of people in the world that are undernourished have increased, has continued to rise in 2020. And I think something worse can be expected, considering the event of the COVID-19 pandemic and what were consequences of that pandemic in terms of lockdown and so on. So it is estimated that between 720 and 811 million people are faced with hunger by 2020, and that represents an increase of 118 million as compared to 2019. And I think this graph as illustrated in this graph. So all this hunger is happening and all this hunger is increasing while the UN SDGs, the goal number 2 of the UN SDGs highlights ending hunger and ensuring access to food for all people, ending all forms of malnutrition, and so on, especially strengthening agri-food systems. So we see that actually we still have a lot of work to do. So unfortunately, this hunger is happening, much of it is happening in Asia, which is having more than half of the people facing hunger, and in Africa with 282 million people suffering from hunger. So if you look at in Africa, in the African continent very closely, you realize that there was an increase from 2019 to 2020, and that is in all parts of the continent, almost all parts of the continent, Central African countries, East African countries, Southern African countries, and West African countries. So when we talk of hunger, we should also think of the hidden hunger, which is a form of malnutrition and a form of undernutrition. And it is characterized by lack of essential, lack of absorption, utilization and absorption of essential vitamins and minerals, such as vitamin A, iron, zinc, carotenoids, and iodine. And currently, more than 3 billion people are faced with this problem, and mostly in those are mostly in Africa, Asia, and Latin America. So hidden hunger has devastating effects, especially leading to mental impairment, poor health, low productivity, and it can even lead to death. And the effects on the child health and survival are very acute. And that starts from the 1,000 days from conception to the age of 2. That is the most critical period of the life of a child in terms of when it comes to hidden hunger. And that results in several issues like physical and cognitive impairments. So when we consider hidden hunger in the world, we see that Africa and some parts of Asia are really much affected, and we have a situation going to very serious to very extremely alarming. And this really calls action from all of us, especially plant breeders who are supposed to produce the crops. So when we zero down to Africa in terms of hidden hunger, we know that it is millions of people, and at least 98 million of preschool age children are affected. And at the continental level, we know that we have approximately 40% of the children under 5 affected. And at the regional level, the prevalence of hidden hunger can vary. Like, for example, we have more prevalence of hidden hunger in East African countries as compared to Southern African countries, and we have West Africa and Central Africa in between the two extremes. Within individual countries, we have the prevalence that can vary also depending on the region and the population and the type of population, groups of population, like regions in terms of urban, where the people are living in urban or rural areas, and also in terms of population, maybe some group of population like ethnic groups or so on, or some group of population that are displaced, that are facing displacement due to conflicts or political instabilities. So when we look at, this is some data that has been produced from 2005 to 2020. And we see that the numbers are very high for Eastern African countries, Central Africa, and West Africa, but mostly from East African countries. So action is really needed in solving the problem of hidden hunger. So hidden hunger has various manifestations, which range from overweight which range from underweight to overweight, and also lead to issues like anemia, stunting, and we see that Africa has most of them. Yeah, so it emphasizes the need of action. And when we look at the consequences of hidden hunger, we see that hidden hunger can affect the human being, the person, at all stages of life, from baby, from newborns to the elderly. And of course, it has different manifestations, various manifestations depending on the life stage of the person. So hidden hunger has consequences, and actually, one of the biggest consequences is that it leads into a vicious cycle of hidden hunger and poverty and stalled development. So at the individual level, we have hungry, malnourished mothers being most likely to give low birth weight to children in a cycle of malnutrition. This leads to diminished physical and mental capacity, compromised health, poor school performance, poverty, limited economic resources. More than 3 billion people are affected, as I said earlier. So that leads to that affects the labor force, the reduced capacity for work, or low paid jobs, low productivity, and so on. And that in turn affects the economy at the national level with the stalled or diminished development like we are facing in Africa. And as a result, we have our government have low capacity to build health and education systems. So hidden hunger also has that type of makes African countries lose a lot of money, especially, and we see that Uganda, for instance, loses up to $145 million every year. That is removed from its GDP, and that is the same also for several other countries, like Tanzania being the highest. We have Tanzania high, Zambia also is very high. So, actually Nigeria is the highest, I should say. Of course, the same also happens in other Asian countries like Pakistan, India, and Bangladesh. So now to address hidden hunger, there are various drivers to consider, and that leads really to the situation of the hidden hunger, and that range from climate variability and extremes to poverty and inequality. And of course, we have conflicts and economic slowdowns and downturns, and that has an effect on the world food system process. And I would like really here to insist on in this presentation. I would like to give some emphasis on the inequality, and of course on the demographic drivers. So several equity issues are related to hidden hunger in Africa, and that include gender inequalities. Women and girls are being often most affected due to limited access to education, healthcare, and economic opportunities. There is disparities between rural and urban areas, with people living in rural areas suffering more of the hidden hunger, and compared to others who live in urban areas. We have poverty, and people living in poverty will consequently lack access to resources such as nutritious food and healthcare. We have ethnic and regional disparities, which also lead to hidden hunger, which also are actually drivers of hidden hunger. We have limited access to information, especially proper nutrition and knowledge and skills for preparing nutritious foods. We have political instabilities and conflicts, which is a major issue, and especially in Africa, where we have a lot of instabilities and conflicts across the continent. So we have also climate change, which leads to more frequent droughts, floods, and other extreme weather events, and that leads to crop yield losses, and resulting in increases in food prices. And it has an emphasis on inequity because it affects most of the low-income populations. So these issues necessitate a solution for properly addressing hidden hunger and ensuring that ensuring access to the necessary resources for a healthy and productive life for everyone. So another vicious circle is the intergenerational effect of hidden hunger and inequity issues, like infants. Once a child faces hidden hunger, it is very likely that that child will grow disadvantaged, especially in terms of school and and productivity, and that will lead to an adult that is also disadvantaged in terms of economic resources because of not having gone to what you call it, not having attended school very well. So therefore, addressing hidden hunger in Africa, we can notice that it is impossible without addressing equity and social justice issues. And addressing hidden hunger requires a we also notice that we also have to recognize that addressing hidden hunger requires a multi-sectoral approach that promotes equity, social justice, and human rights. That won't just involve improving access to food and nutrition, but it also should address the underlying political, socio, and economical determinants of health and inequity. So now pathways for sustainable, towards the sustainable development of human, pathways to sustainable development and human flourishing in Africa. We have all the components, several components that need to be integrated to achieve a transformation of food system, and these include environmental systems, agri-food systems, health systems, and socio protection systems, and other systems. And in terms of food systems, there should be a coherence and complemented among these components. And agri-food systems include crops, fisheries, and forestry systems. And also we have other systems that include education, energy, legal, socio-economic, finance, and trade and marketing systems. So still in the multi-sectorial approach in addressing hidden hunger, we have four actions to be built to achieve four actions to be addressed to be done to achieve food system transformation. And those four actions include food system championing, which is about raising awareness and advocacy, and training on food system approach. We have the second action, which is food system assessment, which involves the food system impact, assessment of food system impact, and actors and institutions that are involved. We have the multi-stakeholder dialogue, understanding views, prioritizing areas and goals, linking interventions. And we have long-term capacity and governance, which involve interagency mechanisms, monitoring mechanisms, and local and national links. So that will lead to food systems, that will involve food system overviews, policy and governance overviews, multi-stakeholder platforms, and so on. I don't want to spend much time here, but I think the diagram and the text can be self-explanatory. So the pathway towards addressing hidden hunger, like we are moving from if we consider one country, for example, we are moving from, we are considering the major drivers of food insecurity and malnutrition being conflict, climate variability, as I mentioned earlier. And to achieve transformation of the food systems, we need to have 6 actions, which include integrating humanitarian development and peace-building policies in conflict-affected areas, scaling up climate resilience across food systems, strengthening resilience of the most vulnerable to economic adversity, intervening along the food supply chain to lower the cost of nutritious foods, etc., etc. So, in technically addressing hidden hunger, of course, we need to act on the food that is eaten by people, and several ways can be done to increase the content of the micronutrients and vitamins in the foods we eat. And those could be through direct supplementation, dietary modification, and diversification. And biofortification. Biofortification has three components. There is the conventional breeding, there is the genetic engineering, and there is agronomic and microbial intervention. Of course, under the conventional breeding, we can have the molecular breeding up to a certain level without including the genetic engineering. I am lucky that my former presenters, have covered most of the technical part of this, from the plant breeding approaches up to the participatory plant breeding approach that is needed in the biofortification. And I'll just highlight a few issues regarding conventional breeding and biofortification. So this is also a bit like the previous one, but of course, mentioned earlier, clarifying that actually conventional breeding and can also include marker-assisted selection and genomic selection that was covered by Dr. Mololo, Dr. Kumi, and Dr. Cosmos. So, how do we use biofortification to address both hidden hunger and equity, or address hidden hunger through addressing equity? And that should be, and it has potential, especially in areas where other biofortification has the potential, especially in areas where other interventions such as food fortification and supplementation are not very feasible. And it allows access, it permits access to essential nutrients to vulnerable populations who may not have access to other sources of nutrition. And biofortified crops, and where it can lead to more inclusiveness and address equity, is that they can be grown and consumed locally once they reach the appropriate people, which will promote sustainable agriculture and reducing reliance on imported foods. So we have to recognize that equity is essential for promoting biofortification and ensuring that vulnerable populations have access to essential micronutrients. And this will, to promote equity, biofortification efforts need to be designed to meet the specific needs and preferences of the local communities. And that I think Dr. Prosi has explained it very well, how to achieve that through a participatory approach. And it should account for factors such as gender, culture, and socioeconomic status. It should engage communities and stakeholders in the biofortification programs. So gender equity is also critical for the success of biofortification efforts, because women and girls are at a greater risk of hidden hunger because of socio and cultural limitations to access regarding access to nutritious food and other resources. Biofortification programs can help to address gender disparities by promoting women's participation in agriculture, making biofortified crops accessible and affordable to women, addressing gender-based barriers to nutrition. So, in the conventional approach of conventional breeding approach of biofortification, we have 6 steps, and I should highlight that all those 6 steps, or most of them, we have 9 steps actually, and most of those 9 steps need to be done in a participatory way, especially in the beginning, like in identification of the target population, identification of the nutritional status of the target population, and setting nutritional targets, the nutrient screening, of course, and so on, until it reaches the level of testing in the target population, improvement, and based on the lessons we learn, improving on the biofortified crops and established effective levels, and so on. So biofortified crops are being used worldwide, and especially in Africa. And they are either released, they are either crops that are released or crops that are going to be released very soon, and that is in many African countries. So we we can see that action is already being taken, though I think more is required. So we have had many programs, especially the Harvest Plus program, that that were involved in funding biofortification efforts in Africa, and we have many technologies that have been released, available to the population. In Uganda and Zambia, we have the orange flesh sweet potato. We have beans for iron content in Uganda and Zimbabwe and Rwanda. We have cassava for vitamin A in Nigeria, Democratic Republic of Congo, Kenya, and maize for vitamin A in Nigeria and Zambia, Zimbabwe, and the Democratic Republic of Congo. And this is a collaboration between funding organizations, CGR centers, and national agricultural research organizations. So also efforts have been made in terms of what is it called again? Genetic engineering in terms of biofortification, and these also have led to the release of several biofortified crops for various micronutrients and vitamins in especially soybean, maize, rice, cassava across Africa. So in conclusion, tackling hidden hunger in Africa requires a multifaceted approach that addresses the root causes of the problem. We can work towards a future Africa where everyone has access to the nutrients they need for a healthy and fulfilling life. That should be done by raising awareness, promoting food fortification and biofortification, supporting local food production, improving access to supplements, and addressing poverty with the participation of all. And of course, there should be a coherent and complementarity in the efforts of the government, the civil society, the other stakeholders such as farmers, and especially NGOs also need to come together and have a coherent and clear programs for addressing hidden hunger. So I talked much about addressing hidden hunger through biofortification. This gentleman is Dr. Buis, which is the founder of Harvest Plus program, and who has really impacted Africa, especially in terms of availing crops that are biofortified for nutrients and micronutrients and vitamins. Thank you. I submit the chair.
Thank you very much, Dr. Baji, for that incredible presentation about actually what is at the center of malnutrition in Africa, the hidden hunger. Indeed, whereas there is some food that's being consumed on several plates across Africa, hidden hunger remains a key hindrance to food and nutritional security. Ladies and gentlemen, it's about 8 minutes past 5 p.m., past 1700 hours, and we were meant to conclude at 1700 hours. Please indulge me for only 5 minutes so that we can come to a conclusion of this webinar today. There are a few questions that are still remaining that I wish to put to some specific panelists for their quick responses. I would like to request that Dr. Cosmos, please, could you make a comment on the few molecular biology laboratories and how we can be able to overcome the skills gaps in managing molecular data for African countries. When you are done, I will also request Dr. Baji to make a comment on how we can handle the trade-offs between having biofortified crops and having the high-yielding varieties. The question by Frejus is such that we have farmers preferring high productive crops varieties, but then the breeding is developing high value fortified crops that do not seem to get a good reception amongst the farmers. And lastly, I will have to take in the comment from Mr. Riek, where he says a number of the challenges in African food security relate to policy issues, socioeconomic issues, insecurity across Africa. And indeed, in my own words, allow me to add that we also have the challenges of climate change and the consequences of COVID. Please, may I hand over now to Dr. Baji and Dr. Cosmos give the quick answers, and then we shall come to the close. There is also a question that any of you can handle on how to handle brain drain in Africa. Whereas we are increasing training across Africa for scientists, agricultural scientists, specifically plant breeders, geneticists, but we have a challenge of brain drain in Africa. How can we be able to answer these challenges? Over to you, Dr. Cosmos.
Okay, thank you very much. That's a very difficult one, and that's a question that has been asked in memorial. My thoughts are, number one, is I think the issue lies with governments. They don't necessarily, most of the people that I see living is not just because of remuneration and benefits at the workplace, but it's because of lack of what to do. I've seen people graduating with masters, people graduating with PhDs from very nice universities, but then they come back to their institute, there is really very little to work on. So this causes people, this is one of the reasons why people keep moving on. Nevertheless, I think that the other reason why we have that brain drain is because at the moment we don't have enough human resource capacity, not capacity, but I mean, I think we don't have the critical mass for human resources. So despite the negative connotation with people living, I think that governments, funders, donors should keep supporting more and more students to do BSc training, master's training, PhD training, and even postgraduate training. In Africa, there's very little offer in terms of postgraduate training when you compare with Europe. With postgraduate training, it can help retain the human resources in the workplace. So those are my quick thoughts on that. Sorry, it may not be the right one, but my thoughts. Thank you.
But indeed, those comments and responses are great and satisfactory, Dr. Cosmos. Thank you very much. Dr. Baji.
Thank you, moderator, and thank you, Dr. Frejus, for asking the question about reconciling the trade-off between yield and nutrient density in crops. And I'm not really sure whether the two are antagonistic. Then I don't know whether there is a yield penalty in developing when doing biofortification. But if there is a yield penalty, and I think one of the first actions is the first to incentivize the farmers or the producers in general, or the consumers, to make the compromise of having low yield but more nutritious. And that should be done by making them understand the consequences, and especially lifetime and intergeneration, the consequences of hidden hunger. And I think that is on a general basis or non-technical. When I say technical, I mean non-plant breeding approach. But the plant breeding approach should also include, of course, that discussion in terms of participatory breeding, and to be more technical, a holistic approach like multi-trait selection approach, a multi-trait genomic regions identification approach, a multi-trait genomic selection approach should be considered, so that like in the multi-trait selection approach, so that selection indices are designed that include both yield and what to call it, and micronutrient content, and of course there maybe add some weight to yield and micronutrient, and see how better to develop varieties that could be having both advantages. In terms of gene discovery or genomic region tracking, also a multi-trait approach would help to not only to increase the power of the statistical method to use, but also it will allow to see the level of pleiotropy or close linkage between the genes that are responsible for yield and the genes that are responsible for micronutrients, some of the micronutrients, the accumulation of some of the micronutrients.
Thank you.
And
thank
of course,
you.
it will also.
Thank you. Thank you very much. Thank you. Thank you very much, Dr. Baji. Time is not our best ally. I am sure Dr. Prose is thinking about the fact that many of the fortified varieties, take a case of the orange fresh sweet potato, with so much incredible nutrients, has not faced the best adoption appeal. Indeed, we have to do more. I am in charge of technology promotion and outreach in the southwestern Uganda. And I can tell you in my interactions with farmers, there is a gap on the farmers taking up the technologies that we so have invested in so much time and resources to develop. On this note, ladies and gentlemen, allow me to pass a thank you to our dear panelists today, Dr. Cosmos, Dr. James, Dr. Frank, Dr. Prosi, and Dr. Afang. It is my singular pleasure to thank you, ladies and gentlemen, for your invaluable time for attending this webinar today. We look forward to hosting you again under the webinar series, Sharing What Works for Africa. The webinar 2 will be coming up soon. Thank you for looking out for these webinars. We look forward to hosting you again. You can pass on your comments and questions on our emails, and you can also please review and listen to the podcast of today's recording on the YouTube channel that has been provided under the chat section. Thank you very much. Please remember to keep working for Africa so that we can secure the food security